Hello everyone, my name is Pino, and in this video we will evaluate the following trigonometric integrals involving the powers of sine and cosine. For our first question, we have to integrate sine squared x multiplied by cos raised to the power 5 of x dx. The sine has a power which is even and the cos has a power which is odd. We take the one with the power which is odd and we break it down. So in this case, the cos raised to the power 5 of x, we break it down and we express it as cos x raised to the power 4 multiplied by cos x, and we further break down the cos of x raised to the power 4 and we express it as cos squared of x raised to the power 2, and this is multiplied by the other cos x. We further break down the cos squared x and we express it as 1 minus sine squared x, and this will be raised to the power 2, and we multiply this by the cos x. In the place of cos x raised to the power 5, we are going to substitute 1 minus sine squared x raised to the power 2 multiplied by the cos x. This will be equals to the integral of sine squared x multiplied by 1 minus sine squared x raised to the power 2 multiplied by the cos x multiplied by the dx. In this case, we are going to let u to be equals to the sine x, and the derivative of the u with respect to x will be equals to the derivative of the sine x, which is equals to cos x, multiplying both sides of the equation by the dx. The du will be equals to cos x multiplied by the dx. So in the place of the cos x dx, we'll substitute the du because it's equals to the cos x dx. In the place of the sine, we substitute the u. So the sine is raised to the power 2, even the u will be raised to the power 2. This will be multiplied by 1 minus sine squared x, and in the place of the sine, we substitute the u, but the sine is raised to the power 2, so even the u will be raised to the power 2, and this will be squared. And like I said, in the place of the cos x dx, we are going to substitute the du. We have the integral of u squared into 1 minus u squared, so we expand 1 minus u squared multiplied by 1 minus u squared du, and this will be equal to the integral of u squared. Distribute first the positive 1 in that parenthesis, so the 1 multiplied by 1 will be equal to 1 multiplied by negative u squared will be equal to negative u squared, and we distribute the negative u squared inside the other parenthesis. Negative u squared multiplied by 1 will be equal to negative u squared, and negative u squared multiplied by negative u squared will be equal to positive u raised to the power 2 plus 2. So the bases are the same, so we add the exponent. 2 plus 2 will be equal to 4 multiplied by the du, and this will be equal to the integral of u squared into 1 minus u squared will be equal to negative 2u squared plus u raised to the power 4 du. We distribute the u squared inside the other parenthesis, and this will be equals to u squared multiplied by 1 will be equals to u squared multiplied by negative 2u squared will be equals to negative 2. The bases are the same, so we add the exponent, so we have u raised to the power 4 plus u squared multiplied by u raised to the power 4. The bases are the same again, so we add the exponent. 2 plus 4 is equal to 6. And this is multiplied by the du. The integral of u squared will be equal to u raised to the power 2 plus 1 divided by the 2 plus 1 minus 2 multiplied by the integral of u raised to the power 4, which will be equal to u raised to the power 4 plus 1 divided by 4 plus 1 plus the integral of u raised to the power 6, which will be equal to u raised to the power 6 plus 1, and this is divided by the 6 plus 1 plus our constant c. We simplify, so we have u raised to the power 2 plus 1, which is equal to 3 divided by 3 minus 2 multiplied by u raised to the power 4 plus 1. 4 plus 1 is equal to 5, and this will be divided by the 5 plus u raised to the power 6 plus 1, which is equal to 7, divided by the 6 plus 1, which is equal to 7, plus c. Remember that we let u, so we let the u to be equal to sine x. So in the place of the u, we substitute back the sine x. Be equals to, in the place of the u, we substitute back the sine of x, but the u is raised to the power 3, so even the sine will be raised to the power 3 divided by 3 minus 2 multiplied by u raised to the power 5. So in the place of the u, we substitute back the sine x, but the u is raised to the power 5, so even the sine will be raised to the power 5, and this will be divided by 5 plus u raised to the power 7. In the place of the u, we substitute back the sine x, and the u is raised to the power 7. Even the sine will be raised to the power 7, and this is divided by 7 plus c. And this will be our final answer. For our second question, we have to evaluate the integral of cos of x raised to the power 3 multiplied by sine x to the power 5. In this case, both the cos and the sine have powers which are odd. So in the case of both powers which are odd, we break and convert the power which is lower. So the cos of x raised to the power 3 will be written as cos squared of x multiplied by cos x, and this is multiplied by the sine of x raised to the power 5 dx. Remember the trigonometric identity, sine squared x plus cos squared x is equal to 1. And when we make cos squared x the subject of the formula, so we'll have cos squared x, which will be equal to 1 minus sine squared x. So in the place of the cos squared x, we'll substitute 1 minus sine squared x. So this will be equal to the integral of 1 minus sine squared x in the place of the cos squared x, and this will be multiplied by the cos x multiplied by sine of x raised to the power 5 dx. Rearrange our integral, so we have the integral of 1 minus sine squared x multiplied by the sine of x raised to the power 5, and we finally multiply with the cos x dx. In this case, we are going to let our u to be equal to the sine x, and we differentiate the u with respect to x, and the derivative of sine x is equal to cos x. We multiply both sides of the equation by dx, and our du will be equal to cos x multiplied by the dx. So we have the integral of 1 minus, in the place of the sine, we substitute the u, but the sine is raised to the power 2, so even the u will be raised to the power 2, but in the place of the sine we substitute the u, but the sine is raised to the power 5, so even the u will be raised to the power 5. So cos x dx is equals to the du, so in the place of that cos x dx we'll substitute the du. From here we have the integral. We distribute the u raised to the power 5 inside the parentheses. U to the power 5 multiplied by 1 will be equals to u to the power 5 minus u to the power 5 multiplied by negative u squared will be equals to u to the power 7. So the bases are the same, so we add the exponents. From here, this is just standard integrals. The integral of u to the power 5 with respect to u will be equals to u to the power 5 plus 1 divided by the 5 plus 1 minus the integral of u to the power 7 will be equals to u to the power 7 plus 1 divided by the 7 plus 1, and we have our constant c. So u to the power 5 plus 1 is equals to 6 divided by 6 minus u to the power 7 plus 1 is equals to 8 divided by 8 plus our constant c. Remember that our u was equals to sine x, so in the place of the u we'll substitute back the sine x. So we'll have the integral of, in the place of the u we substitute sine x, but the u is raised to the power 6, so we'll raise the sine to the power 6 divided by 6 minus the sine x in the place of the u, but the u is raised to the power 8, so we also raise the sine x to the power 8, and this will be divided by the 8 plus our constant c. We have to evaluate the integral of cos squared x multiplied by sine x to the power 4. In this case, the sine and the cos have even powers, so we are going to substitute them for double angle identities. But before that, we have the integral of cos squared of x and the sine of x to the power 4. We express it as sine squared x raised to the power 2 dx, and the double angle identity for cos squared x is equals to half into 1 plus cos 2x, and the double angle identity for sine squared x is equals to half into 1 minus cos 2x. In the place of the cos squared x, we substitute 1 over 2 into 1 plus cos 2x, and in the place of the sine squared x, we substitute 1 over 2 multiplied by 1 minus cos 2x. Since the sine squared x itself is raised to the power 2, so even this will be raised to the power 2 dx, and this will be equals to the integral of 1 over 2 into 1 plus cos 2x. The square is affecting both the half and the 1 minus cos 2x, so 1 over 2 squared will be equals to 1 over 4 multiplied by 1 minus cos 2x squared dx. The 1 over 2 multiplied by that 1 over 4 will be equals to 1 over 8, and we push them out of the integral since they won't affect the integration process, so we'll be left with the integral of 1 plus cos 2x into 1 minus cos 2x raised to the power 2 dx, and 1 over 8 multiplied by the integral of 1 plus cos 2x multiplied by the 1 minus cos 2x squared will be equals to the 1 squared, which is 1, and the 2 multiplied by the 1 multiplied by the negative cos 2x will be equals to negative 2 cos 2x, and the negative cos 2x squared will be equals to positive cos squared of 2x. So if you're not comfortable with this method, you can go ahead and expand. You will get the same answer, and this will be equals to 1 over 8 multiplied by the integral of, we distribute the 1 inside the parentheses, and the 1 multiplied by that 1 will be equals to 1, and the 1 multiplied by the negative 2 cos 2x will be equals to negative 2 cos 2x, and the 1 multiplied by the cos squared of 2x will be equals to positive cos squared of 2x. We distribute the cos 2x inside the parentheses. The cos 2x multiplied by the 1 will be equals to positive cos 2x, and the cos 2x multiplied by the negative 2 cos 2x will be equals to negative 2 cos squared of 2x, and the cos 2x multiplied by the cos squared of 2x will be equals to positive cos cube of 2x. We have the dx. From here we can group the like terms. So we have 1 and the negative 2 cos 2x plus the cos 2x will be equals to negative cos 2x. The cos squared of 2x minus the 2 cos squared of 2x will be equals to negative cos squared of 2x. We also have the plus cos cube of 2x and the dx. From here we have 1 over 8 multiplied by the integral of, so we have the 1 minus, so we have that cos squared of 2x and the minus cos 2x plus the cos of 2x raised to the power 3 dx. Remember the trigonometric identity, sine squared a plus cos squared a is equals to 1, and sine squared a will be equals to 1 minus cos squared a. So we have the same scenario here where the a is equals to 2x. So in the place of 1 minus cos squared of 2x, we will substitute sine squared of 2x. So this will be equals to 1 over 8 multiplied by the integral of, in the place of this we substitute sine squared of 2x, and we have the negative cos 2x plus cos 2x raised to the power 3 dx. 1 over 8 multiplied by the integral of, So we can use the double angle identity again to express sine squared of 2x, and this will be equals to 1 over 2 into 1 minus cos 4x. The double of the 2x is the 4x minus cos 2x plus cos 2x raised to the power 3 dx. We distribute the half, so we have 1 over 8 multiplied by the integral of, so the half multiplied by that one, and the half multiplied by the negative cos of 4x, and this will be equals to 1 over 2 minus 1 over 2 multiplied by the cos of 4x minus cos 2x plus cos 2x raised to the power 3 dx. So we have 1 over 8 multiplied by the integral of 1 over 2, which will be equals to 1 over 2x minus 1 over 2 multiplied by the integral of cos 4x, which is equals to sine of 4x divided by the 4 minus the integral of cos 2x will be equals to sine 2x divided by the 2 plus the integral of cos cube of 2x dx, which we do separately. So we evaluate the integral of cos cube of 2x dx. We express this as cos squared of 2x multiplied by cos 2x dx, and we write the trigonometric identity sine squared of 2x plus cos squared of 2x is equals to 1, making the cos squared 2x the subject of the formula. So we'll have the cos squared of 2x, and this will be equals to the 1, and we take the positive sine squared 2x to the change sign to negative sine squared of 2x. So in the place of the cos squared 2x, we substitute 1 minus sine squared of 2x, and this will be multiplied by the cos 2x multiplied by the dx. We let u to be equals to the sine 2x, and the derivative of the u with respect to x will be equals to the derivative of the sine 2x, which is equals to cos 2x. And according to the chain rule, we have to multiply this by the derivative of the inner function, the 2x. So the derivative of the 2x will be equals to 2. Multiplying both sides of the equation by the dx, du will be equals to the 2 multiplied by the cos 2x multiplied by the dx. This will be equals to the integral of 1 minus sine squared of 2x. So in the place of the sine 2x, we substitute the u, but the sine 2x is raised to the power 2, so even the u will be raised to the power 2, and we have the cos 2x dx. So let's divide both sides of this equation by 2, and du over 2 will be equals to cos 2x dx. So in the place of the cos 2x dx, we substitute du divided by 2. So we can push that half out of the integral, and we'll have the integral of 1 minus u squared du and this will be equals to half multiplied by the integral of 1 with respect to u will be equals to u, and the integral of negative u squared with respect to u will be equals to negative u raised to the power 2 plus 1 divided by the 2 plus 1. We can omit the c for now, and we have the half into u minus u raised to the power 2 plus 1, which is equals to 3 divided by 3. We can omit the c for now. This will be equals to the half multiplied by the u, but in the place of the u, let's substitute back the sine 2x. One over 2 multiplied by the 1 over 3 will be equals to 1 over 6, and in the place of the u, we substitute the sine 2x, and the u is raised to the power 3, so even the sine 2x will be raised to the power 3. So let's copy and paste that, and the integral of cos 2x raised to the power 3, and we determine that it's equals to 1 over 2 multiplied by the sine 2x minus 1 over 6 multiplied by the sine 2x raised to the power 3, and we close the brackets, and let's include the plus c. So from here, let's try to simplify. So this negative sine 2x divided by 2 plus that 1 over 2 multiplied by the sine 2x, they are like terms and they will cancel out each other, since the other one is positive and the other one is negative, and they are both half. So we'll have the 1 over 8 into 1 over 2 multiplied by x minus sine 4x divided by 2 multiplied by 1 over 4 will be equals to 1 over 8, and these two will cancel out. Negative sine of 2x raised to the power 3 divided by 6 plus c, and this will be our answer.